Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Izzuddin. To begin our group presentation, I will explain to you about background of the project. Deciding what to eat has become increasingly difficult due to the vast number of available food options and the diversity in personal taste, preference, and dietary needs. The traditional methods, which is browsing the menus and food apps, are often time consuming and fail to provide personalized or satisfying results. To address this issue, a food recommendation system is proposed that utilizes the content based filtering and consign similarity. This system will analyze the user preference and nutritional goals to deliver fast, accurate, and personalized meal suggestion, helping the users make better food choices with less effort. Moving on to the next part, which is the project objective. We have three objectives for this project, which is the first one is to design machine learning system that can provide users with food suggestion by using the cosine similarity algorithm and content-based filtering. The second one is to simplify the process of deciding on foods by analyzing and suggesting the dishes that meet the user's requirements. The last one is to improve user experience and promote a better food discovery through tailored and data-driven recommendations. The next part is about the model objective. The first one is to be able to match the user preferences with the dataset feature similarity by applying the cosine similarity algorithm with the content-based filtering technique. The second one is to ensure the model is scalable and computationally efficient for the real-time recommendations. The third objective is to successfully get an accurate suggestion of foods that are similar to the user's taste preferences.
Assalamualaikum warahmatullahi wabarakatuh. So for our project, we use content-based filtering. So content-based filtering basically uses the features or attributes of an item to give other similar recommendation to the user. And this recommendation system describes the product using keywords and builds the user profile that express the type of item they prefer. So in simpler terms, the system will look at details of items that the user likes and find other product with similar features. Okay, so for the next one is cosine similarity. So in this project, cosine similarity is being used to calculate the similarity of the user input with the data set features. So cosine similarity algorithms calculate the similarity by using the cosine angle between two vectors, for example A and B, which can represent by using words, sentences, paragraphs, or even the entire documents. So this technique has been widely used in many aspects to help match the user preference with items. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fazil Razin Birajinda. Today I will be explaining for the data set of our project. So our project uses a data set that represents data for food recommended system from Kaggle. It is in the form of CSV, and this data set contains data related to the foods, ingredients, and cuisine involved. There are 400 unique values of foods, which consists of 22% Indian foods, 14 healthy foods, and 64% other type of cuisines. The food dataset can also be categorized into type of food, which is vegan and non-vegan, where there are about 60% and 60% vegan and 40% non-vegan. Other than that, there is also the describe column, which contains the ingredients of the food and there are about 397 unique values of the ingredient in this dataset. Bismillahirrahmanirrahim. My name is Shafiq bin Yusni, metric number 2200697. Now I will demonstrate our AI system. In the first step, we perform data pre-processing. We access our dataset from Google Drive and save it in a data frame. So this is our original dataset. It contains 5 columns, which are food ID, name, cuisine type, veg or none, and also describe. We also want to check whether our dataset contains any duplicated rows or whether any of the columns contain missing values. So from this simple line of code, we can verify that there are no duplicated rows, neither missing values in any of the column in our dataset. Next, we want to identify the most common ingredients in our dataset. We do so by vectorizing the describe column, and we rank the sum of TF IDF scores. We print the 50 words with highest TF IDF scores, and we from there we know what are the most common ingredients in our dataset. Based on this, we manually create a flavor to ingredients dictionary. So it contains several flavors that we manually type in, and we invert the dictionary to become ingredients to flavors for machine readability. And after that, we parse from the describe column and save it in a new column called ingredients for the next step. In the next step, we pre-process the ingredients column, which is we want to clean the text using regular expression. Uh, we remove any symbols or punctuations, and also we remove the auxiliary words such as fresh, chopped, minced, etc. to get only relevant ingredients. We add the clean ingredients in a new column called ingredients clean. So this is the result of the ingredients clean column. Now we are at the process of feature extraction. We want to map the ingredients of each food to corresponding flavors using fuzzy matching. We choose fuzzy matching technique because it offers a more flexible matching between two strings, and it is suitable for datasets like ours, which may contain noisy or inconsistent keywords. So, food that are mapped to flavor, we save it in a column called flavors. We want to check because some of the food may contain uncommon ingredients. It may not have any flavor mapping. So we want to check how many rows in our dataset did not did not map to any flavors. So we found that there are 21 rows out of 400 rows in our dataset that was not mapped to any flavor. Uh, Next, we will build soup column, or commonly also known as tag column. So this soup column consists of 3 other columns, which are flavors, cuisine, and ingredients. We just uh, append them all together in a and remove all commas and any un, unrelated elements, so that the remaining column will only have meaningful
keywords to be passed into our recommendation logics. So now uh, we are at the recommendation logic step. From the sub column, we will vectorize it to convert it into numerical form. We vectorize using count vectorizer. So when it's converted into numerical form, we can perform mathematical operations such as cosine similarity. So this is function to recommend from user input. So basically, we will take two input from user, which is we ask which ingredient the user wants to have in the food and what flavor are they looking for in the food, and we pass those two input into the function along with other parameters. So the in this function we will perform the same tax cleaning process as we did earlier to create the user soup. And after we have got a user soup, we vectorize it in order to perform cosine similarity with the count matrix from our data frame earlier. So from the cosine similarity, we will compare which food has the closest score to our user vector soup. So that is how our recommendation logic works. So I'll show some demonstration of this recommendation logic. So for example, if the user is craving for chicken and they want it to be spicy, so these are the recommendations that our system will give to the user. We see the results are relevant and it contains chicken, and if we check the ingredients of each food, they indeed contain spicy ingredients. So that's all for the demonstration part. Pass to the next presenter. Thank you.
Lastly, to conclude everything, this group project focused on developing a personalized food recommender system with all the contribution to its success. Shafiq handled the dataset preparation and pre-processing. Faz- Fazrin implemented the vectorizer and recommendation model with my assistant, while my part in this project is on the literature review and the project background, also with the objective. The main goal of suggesting food based on user preference and ingredients was successfully achieved in this project, even though the deployment was limited to Google Colab due to the time constraint. The future improvement that can be made by our group is to include deploying the system on a website or apps, expanding the dataset, and adding more interactive features like craving-based suggestions. Overall, the project provided valuable hands-on experience in machine learning and AI, laying the groundwork for future development in intelligent recommender system.